morning, people. I hope you're doing well, my delovelies. So, let me bring you an offering. I warn you, of course, that it may contain science. Hot science. Well, the hot science may have cooled somewhat. Oh, actually, you know what? Given its origin, it may not have. We'll have to see. But it's science that has taken its time to come to the fore because it has been stealthing right in front of our face. All right. So remember Venusian phosphine. In 2020 and 2021, there was this huge back and forth about whether those findings were for real, in part because the stakes were so high. The presence of high levels of phosphine were considered suggestive of life, not because that's the only way phosphine could be produced on Venus, but ostensibly because the other means of phosphine production had been ruled out. There's no evidence of lightning on Venus, there was no meteor strike. We would have noticed, since we have the mother's maiden name and social security number of every significant asteroid from here to Jupiter, which, once again, is why Armageddon is the official cinematic rage fuel of May Contain Science. So no lightning, no meteor strike, and no volcanism on Venus. Scientists ruled all that out, which is why the phosphine finding was so noteworthy. I'm told when you have eliminated the impossible, whatever remains, however improbable, must be the truth. I mean, that works for Sherlock Holmes. But science does things just a bit differently. Because before you accept the improbable, you gotta make absolutely sure that the impossible was properly eliminated. 2.5 years ago, that meant every astronomer from here to Mare Cognitum leaned over Team Phosphine's shoulder to check their work. It was a whole thing. There was a dog pile over Team Phosphine's math and back and forth. Well, it's like one of those superhero fights where the two are in combat and it's like, wham, shh. And before you can figure out which superhero would really win in the fight, the villain busts in like, "Aren't you both forgetting someone?" The villain in this metaphor is Venusian volcanism. See, it's not that Team Phosphine thought that Venus was never volcanic. It very much, extremely was. Back in the 90s, the Magellan missions mapped about 95% of Venus's surface using synthetic aperture radar, which gives us a perspective on the topography of Venus's surface. Scientists at Caltech wrote an algorithm to identify the surface features suggestive of volcanoes. And overall, they estimate that Venus has more than 1,600 volcanic landforms on its surface, and good evidence to suggest that Venus itself has been repeatedly resurfaced by lava flood. In fact, while the Earth was going through the Cambrian explosion and evolving honest to mollusk animals, Venus, meanwhile, appears to have had a global lava flood that resurfaced like the whole planet, which might contextualize why its surface is made like 95% of basalt, a rock formed by lava. It was never that Venus didn't have volcanoes, it was that we never had any confirmation of active volcanoes, anything that could have instigated those phosphine reactions. At least we didn't have confirmation of active volcanoes until now. Enter Robert Herrick and Scott Hensley. Herrick is a geophysicist at the University of Alaska at Fairbanks, and Scott Hensley is at JPL and uses differential geometry to develop advanced radar techniques. Together, they fight crime. Wait, no, that's a different segment. All right, what Herrick and Hensley did was go back over the Magellan data from the 1990s. Magellan, on that mission, spent 4.5 years orbiting Venus and collecting this radar data, which is one of the few ways to map Venus's surface through those freaking clouds. at the end of Magellan's mission, we had a big pile of data. You could almost call it a haystack. And when I tell you, these researchers laboriously trawled through this haystack, it's because Magellan didn't just map Venus's surface. Over those 4.5 years, it didn't just capture the whole surface of Venus once. Magellan captured data from some places multiple times, allowing Herrick and Hensley to look at changes to those locations over time. And this is a planet whose floor is actually lava, so if the surface changes, well, it's not going to have changed from deforestation, let's put it that way. Because Magellan didn't capture the whole surface multiple times, our geophysicists were at least able to shrink down their haystack somewhat. From there, they further filtered footage by focusing on likely volcanic regions, but even with that Venn diagram, this is a pretty agonizing guess and check of the surface of a planet. For reference, here is a radar image from Magellan showing Venus lava flows. The width of this image represents 140 kilometers. That is roughly 87 miles in freedom units. For reference, this Google Earth image, roughly centered on Los Angeles, is also 140 kilometers wide. You couldn't even fit LA to San Diego into that. Now, imagine finding a volcano somewhere in the world while looking at this scale. Overall, these scientists put hundreds of hours into this search with no guarantee they'd ever find anything. They estimate that even now, after publication, after those hundreds of hours, they've only examined about 1.5% of Magellan's data. And even if some number of these locations had active volcanoes, there would have had to have been some sign of their activity specifically in the time frame that Magellan was searching. More, really, than signs of activity. After all, there had been such signs, like thermal anomalies and temporary concentrations of sulfur dioxide. Is Venus doomed to give off ambiguous data forever? Well, no. Their story has made it to this segment, and their findings made it to the journal Science, so it's safe to say that their hundreds of hours were not in vain. North of the summit of Moot Mons, the highest volcano on Venus and second highest mountain on the planet, our scientists found this: a change in shape in the volcanic vent between February 1991, when Magellan made its first pass, and again later that year in October, when Magellan went back again and saw a volcanic crater appeared to double in size while also becoming shallower. The most straightforward explanation appears to be that the crater collapsed and filled in with fresh lava, like a sand mountain filling with water, but less like my little kid at a beach experiences, and, well, I suppose more like a freaking volcano filled with lava. Still, you may think from this picture that it's not 100,000% dispositive from the image alone, and you would be right. Radar images aren't perfectly reliable. Depending on the perspective from which the picture is taken, the appearance can change significantly. There's a finite amount our geophysicists could do to improve their certainty about the conclusion. You can't really zoom and enhance a radar image. But, you know that thing about how you don't have to outrun the tiger, you just have to outrun the other guy? Well, scientifically, when you can't do more to establish the truth of your hypothesis, you sometimes can still outrun the other hypotheses. That is, show that the other possible explanations don't fit as well to the available data as yours. So, in addition to actually finding this change on Moot Mons, our researchers also modeled this alongside other explanations for the change in imagery to show that Of all of the most likely candidate explanations, volcanic activity explained the changes better than possible radar imagery issues between February and October 1991. And that tiger hypothesis approach goes a surprisingly long way in making this study a confirmation rather than supportive evidence. Those signs of activity we've seen before, thermal anomalies and atmospheric sulfur dioxide, were certainly suggestive of volcanic activity, but there are also many alternative explanations for those phenomena, and it's much harder to rule out those alternatives than with radar image issues. Unless and until we can reasonably send probes that won't shrivel up from pure Venusian misery to observe volcanism directly, this study has the highest certainty of anything we've seen so far. And it may be the best we can do with this kind of data. It's not seeing it with our eyeballs, but when you put the whole picture together, Herrick and Hensley have made a pretty convincing case. Overall, this volcanic feature is the only one that has been identified as active, this one on Mons, and the kilometer scale radar observations of Earth, which accounted for 25% of the Venus surface, never found anything. So, our geophysicists suspect that Venus is not going to be quite as active as, say, Jupiter's Io, which has like 100 confirmed active volcanoes. Venus may be past its heyday of the floor is lava, but it's not quite done yet. There's at least one hot spot out there.